Hello, my name is Santiago Martinez, and today we're going to be reviewing problem 2 of exam 3. This is a relatively simple problem, but it's good to go over and utilize in a couple problems in the future for this exam. This exam is going over unit circle and trig functions, so it's important to know your unit circle. I have it right here, just so we can refer to it if needed, and a couple other information that will be helpful to use. Also, with that being said, there are certain formulas and equations that we can use. Feel free to look them up when I say them, because this is provided in the exam as well. So it's free to use them and not necessarily memorize them. You should memorize them and you should have your identities memorized, but certain properties is okay to look at the sheet for. And I'll reference that sheet and say if I'm using an equation from that sheet or if not. So this question is asking us to convert 31 pi over 12 to degrees, I should say. And then it asks as a side question, what quad, as in quadrant, is it in? So starting off the bat, you need to know what your conversions are off the top of your head. So one that I like to use immediately, and if you took chemistry or physics, you'll understand dimensional analysis. And what that is that we try to get rid of whatever we're trying to get rid of by you either putting on the top or the opposite of what it's in. So if I have a value on top, I want my canceling value to be in the bottom of our next fraction, and vice versa. You'll see it here, but let's notate what our conversion is. So we know for at 180 degrees that is also equal to pi, right? So we can use this interchangeable to go from degrees to radians as necessary. So for example, you want to go to degrees. So we have 31 pi over 12 times, we want to get rid of pi, so we do pi on the bottom, over 180. And this is a pretty big number if you do it like this, but of course we can always simplify. So how can we simplify to make this much easier? Looking at this, we can cancel this out to be 12 goes into 180, I believe 30 times, and we can check that as it would not be hard. Let's see. 12 times 1. This is how you would check this. 180. 30 seems a little bit big. It might be 15 but like I said, this is problem analysis. We have to be able to check multiple answers and see if we're correct. If you're smarter than me, you could probably just logic it out. But again, I don't feel like I'm that wise. See, you can already tell that something's off here because we're going to get 16. We're going to get 20, so this number is going to be way too big. So we can do 12, which I believe it's going to be 15. This is going to be 10, 5, 6, 0, 2, 1. And that's 180. So there we go. We have figured that out successfully. So this is 15. That's 1. And now we multiply 31 by 15. 5, 15, 0. That's 1, that's 3, 5, 6, 4. So we should get 465 degrees. So looking at this, right, we know that the pi cancels out, and then we just multiply straight across through 15 using our conversions, right? So now going down here to figure out what quadrant it is. This is a little too big to figure out what quadrant it exactly is. So we take 465 minus a full revolution or a full degree cycle, which is a 360. So 465 minus 360, 5, 0, 1. So this is going to be 105. And we know off the memorization of our unit circle, and I'll show you here, that this terminal is 90. This terminal is 180, 105 degrees fits somewhere in here. And this would be quadrant 2 is the location of our degrees. Pretty simple stuff. Make sure you know your conversions. And that was problem 2. Thank you.